We'll get started here in a couple minutes. Before we get started, though, I have a question for the room. So who here understands what threat intelligence is, and what kind of things are you looking for in this talk? I'll start on the left here and just kind of move our way through here. Okay. So when you hear threat intelligence, what is that? What part of your experience with computers and security and all that, what part does that pique?
So for me, it's like threat hunting.
Threat hunting?
You know, like seeing the basically defenders, you know, it's like seeing the graphs, seeing how the threat played out, like with a person, you know, where they logged in and
Patterns.
their patterns.
Yeah.
And credentials and
okay. What else? What other?
Just general trends.
General trends.
So what types of threats are out there? What vectors are? State-sponsored attacks? Is it ransomware? What types of ransomware? How are they? Just I think of threat intelligence. I think of what to be looking for.
Okay. The patterns, trends.
IOCs for us.
IOCs. So indicators.
Or what we haven't seen that's new, or we can draw correlations.
Okay.
Burn down's real important. That IP that's super sweet off Cloudflare can stay in the system forever. Soft.
Okay.
What new tactics are they using? What vectors are they using?
Tools, techniques, tactics. Yes. All of these things. So this is all good information, and I'm really glad that we have this awareness out in the community. When I originally kind of stepped into this project, this is something that I knew that this had been brought up as a tool before. This decides to cooperate. There we go. I had seen MISP used, and there was a talk briefly at SecKC, and the takeaway I had at that was you need to be using MISP. And why is this automatically? Well, in any case, so there was this tool out there, and I knew it existed, and I knew that there were some excellent professionals out there who really enjoyed it, but I didn't fully understand why. And so about a year ago, I sat down and kind of started chewing on this question. And then every time I kind of brought up the tool, took a look at it, it started bringing up more questions. So before I get along too far here, my name is Joel Kershner. I work for the University of Kansas. I'm a senior information security analyst. My role and responsibility is mostly incident response and policy and that kind of stuff. So mostly I'm just kind of the grunt worker behind a lot of these big processes that we have in information security at KU. So one of the goals I had in trying to get into this project was I wanted to figure out how to utilize threat intelligence sources and feeds, because there's a ton of them out there. And then I was really interested in finding ways to communicate threat intelligence information. And then also I wanted to find out more about how to use it for collaboration amongst people, amongst practitioners. And so that was kind of really, that's kind of when I was going into this is kind of where I wanted to go with it. Before we get into the depths of what the MISP tool is, I wanted to talk a little bit about threat intelligence. What is it? And when you're looking at the MISP tool, it does a lot of stuff. It is a Swiss Army chainsaw. So think about this. This is an object. If you'd never seen this before, if you didn't know what it was when you first looked at it, what would you think this was? It has a lot of metal to it. There's a lot of tools here. But what is its main function? going back over this from the history of it, we know that this is a Swiss Army knife. It is a knife with lots of tools with it, but that's its intended function. Though it's kind of hard to look at it up front and think that. So one of the, so I'm gonna go over some of the objectives here. First, I want to go into the process that feeds and what MISP is intended to work with, and this is threat intelligence. I'm gonna go into how to work with threat intelligence feeds and try to evaluate them. And this is not so much to teach you about threat intelligence, this is to give you context. Why is this thing? So, context, because the tool itself is very diverse. So it's important to know the mindset going into trying to use it. So we're going to talk about threat intelligence, we're going to talk about the MISP application, and then kind of not only what it's intended to do, how it fits into the threat intelligence process, but also we're going to talk about just basic steps on how to create a new event inside of MISP, and then how you can share information both within entities inside your instance of MISP and other federated entities. And I'll go over some lessons learned. So starting out here, threat intelligence. So we have a couple different definitions here. The first one here is from Wikipedia, and it says it's a cyclical practice. So threat intelligence as a practice. And then we have NIST, which defines it as this is a product. So which is it? Is it a practice or a product? So really, how do you gauge quality on threat intelligence? And that's where the practice comes in. The more you can put into processing, analyzing, and filtering and controlling your threat intelligence process, the better the product will be. So threat intelligence is an overloaded term, but really it is a process that generates a product. So a process, in its essence, is basically a project. This is not new territory here. I think everybody here has dealt with project management in some level or another. You know, you got initiation, planning, execution, monitoring, controlling, closing, and then looping around for continual process improvement. But this is, if you're trying to answer a question, you start up a project, and that project will, as a core reason for being, it will generate a product. And so inside of this project, you'll have the threat intelligence lifecycle. The threat intelligence lifecycle is planning and direction, collection, analysis, production, and documentation and feedback. So this is kind of the nuts and bolts of generating threat intelligence. And so this threat intelligence product, why is this doing this? Well, I'll never know. But the core reason for being is that what is threat intelligence? It can be anything from a list of IP addresses to domain names to tactics seen from a threat actor. It can be anything, but the creation of that, anybody can create threat intelligence, but it's not always good quality. And so that's the core here. You want to make a good quality product. So in threat intelligence, you likely have numerous sources. It can be anything from CISA to other colleges, other universities, other government entities giving you threat intelligence information. You get a constant stream of this. And you have this big mess of data that you have to make sense of. So evaluating a data source is a good idea. And the value of doing this, and it can be any source really, it can be your log management system. You may have 50 different log management sources, each of them generating something similar. And you need to figure out which ones to keep around because it's expensive to have that much data stored, especially for long periods of time. So this is a way of making efficient use of your storage and time. One thing I will say is that I have not seen a single all-encompassing standard. And that, like I said, I've been kind of looking at this for about a year. So this is not the end all be all of data source evaluation or analysis. There's a lot more depth to be had here. So just keep that in mind. This is my personal take on it. So when you're looking at an individual data source, let's take, for instance, you're looking at your AD authentication logs. These are very valuable for incident response. And this is a good source of information. And from this, you can generate potentially some good threat intelligence. Some dimensions of quality for this source could be accuracy, completeness, uniqueness, validity, timeliness, consistency, credibility, and reliability. And there's a certain set of questions that will give you an answer to each of these dimensions of quality. Right. Come on, there we go. So here's a few ways to get information about these dimensions. And so, like, for instance, sources. Where did you get this source? Is it from your servers? Okay, then that's going to be pretty reliable. But if you're getting this from somebody else, you want to evaluate whoever, if you got it from a person, you want to evaluate, is this firsthand information, secondhand information? You want to figure out what was used to correlate these findings. So there's a lot of questions here, and each of these will answer some of the questions on dimensions of quality. So when you're trying, well, once you've gone through and you've evaluated your sources, you've gone through and asked a lot of these questions on trying to identify what is a quality source of information, how do you communicate that? Either internally or to people outside your organization. And there's a few standards out there. For instance, NATO has the Admiralty Code, which is mostly dealing with the reliability and consistency of a data source. It's a alphanumeric code, A through F and 1 through 6, where A is most reliable, F is least reliable, 1 is, 1 is most consistent, and 6 is least consistent. And so you would get a code, C3. So that's one way you can communicate with a piece of data that you've generated that this is its reliability and consistency. There's something else that you'll see sometimes in threat intelligence called the analytic confidence score, which is a percentage score. And it varies. So Microsoft has something where they have kind of a list of, it's really kind of a gut check is what it comes down to. It's how much effort that went into the checking of this piece of information. And so it's percentage. 0 to 50 is usually low confidence. 50 to 80 is kind of intermediate. And then 80 to 100 is high confidence. But reasons why they would choose a specific percentage score, I haven't really seen anything big and consistent on that. So it's, yeah, that's just my 2 cents on what it is. So how many questions have you asked about that data? And then that would turn it into a percentage score, which is how much work have you put into verifying it. You could do a qualitative categorical method where you go through the dimensions of quality that I mentioned earlier, give it a rating of 1 to 5, and then either generate some type of weighted average or average. And maybe that would give you kind of a good internal score on log data or threat intelligence data that you could potentially evaluate which source is better than the other. So what is MISP? It is an open source product. It is a web application. So right now, development is primarily funded by the European Union, and that makes sense. European Union they have a lot of borders to cross, a lot of different cultures, and they need to be able to communicate threat information with each other and quickly and within standards. Some of the use cases that you might find within education is providing access to a stream of open source intelligence or threat metadata between different organizations. You could potentially use it for case management, although there's some caveats to that. You can potentially go through and catalog event information, standard format. All of this is accessible using an API interface, and so you can potentially use it for your SIM and doing enrichment. And so that's very, very useful. It adds context to your incoming logs and gives you kind of a means of, it gives you a story. So if you see an IP address that's CISA has warned is a ransomware actor inside your logs, that's good information to know. Gives you good context. Another thing is that it supports multiple unique organizations or affiliates within one web application. And so you can have potentially multiple organizations participating in one instance. So it's great for a university environment where you have multiple stakeholders. So potentially you might have multiple security organizations within the university environment that may need, to have a stake in communication for threats. Use case that I think has a lot of merit is sharing block lists. So each person in this room has at some point generated threat intelligence or a block list, whether it's reporting phishing or it's been reporting a malicious IP address or a cloud provider that has a threat actor renting infrastructure on it. And we have come to the conclusion that it is bad and we want to block it. That's very valuable information. And that's information that you may want to share because it's valuable to everybody, in your group, whether it's within the university organization or it's within the education community itself. It's a useful piece of information to share, and you want to do so quickly and effectively. That's not always really viable to do with an email. Emails take a long time. Deliverability is a question mark these days, and even whether somebody has time to read it and process it. Also, if you send an email, sometimes it's a PDF, sometimes it's a piece of text inside of an email, and it's sometimes difficult for people to pick out all the relevant indicators of compromise from that message and utilize it. It would be much nicer to have some type of common format, such as a CSV file or a JSON file or something like that, where we could easily and quickly communicate that and automate it if necessary. Some of the other output features that MISP has, you can also directly output snort IDS rules. And so that's also a very useful thing to have. Collaboration by itself, MISP would need to make heavy use of tags to emulate a case management system, and it shares by default. But when you're collaborating with people, it has a lot of features that make collaboration very useful. Timelines. So that's when we're making reporting. That's one of the key things that people really like is a timeline. So it gives you kind of a scope. And then some other things that MISP offers is standardized tagging and system taxonomy. So whenever you have a system that you use, security system, it will allow you to use custom tags, and usually somebody has to type that in manually. And you have 50 different capitalizations and spellings that you have to deal with. And that causes a big mess when you're trying to use tags as a part of an automation or something like that. So having a standard there is very helpful. having the MITRE at ATT and CK integration, so you can have tactics clearly listed in the MITRE ATT and CK framework and have that as part of some of its reporting is also very useful. So some different ways that you can get started with threat intelligence. Joining an ISAC, Information Sharing and Analysis Center, and there's tons of them out there. We have, and it varies. So a ISAC can either provide lots of shared services, such as a SOC that you can make use of, getting group deals on tools, any number of things, or it can just be as simple as, meeting up in a, once a month and trading war stories over, a beverage of choice. You can also potentially use this to document high-level observed attacker and tactics. And so, for instance, an example of organizations that a university would be a part of would be RIN ISAC and MS ISAC. So RIN ISAC is Research and Education Networks and Information Sharing and Analysis Center. And MS ISAC is Multi-State Information Sharing and Analysis Center. So both of them have different target audiences. So RIN ISAC is mostly focused on the educational arena as well as research, and MS is mostly government. But these are great sources of threat intelligence. If you are not a member of some of these, of RIN ISAC or any of that, there's other core infrastructure ISACs out there. There's a ton of them. And so you can go to nationalisacs.org, and if you're in energy or if you're in water processing or anything like that, there's probably an ISAC group for that. Now, you also have undoubtedly utilized free and freemium threat intelligence sources along with paid sources. And that can be anything from VirusTotal, gray noise, emerging threats. There's a ton of these sources out there. And this is kind of a problem because we have this big pile of information coming towards us, and we don't know its quality. So that's kind of one of the question marks here, and that's one of the values of going through and performing kind of analysis on it to check and see which one of these sources is accurate, or if it's a duplicate of something else you're already receiving or something like that. Paid sources are really nice. So it's a curated feed of threat intelligence information. So the great part about it is that if you get a finding where an IP address is said to be malicious and you block it, and then it also blocks a critical service that you're using, you can go to them and say, hey, can you tell me why you came to this conclusion? Why is this malicious? And they said, well, it's a brand new website, and oftentimes threat intelligence vendors such as Palo Alto, when they come up with a new website categorization, they'll go through and they'll just base it off of, okay, this is less than 30 days old, and it's a couple words juxtaposed, therefore it must be malicious. So it's important to have that dialogue with the people generating information so you know why it did it. Otherwise, with an open source feed, you may not know why. And so you have to make the hard decision. Do I just allow this and hope everything goes well? Or is there something really going on there that I should be aware of? So the tool ecosystem, kind of like part of a balanced breakfast. So we have all kinds of tools in our environments. It's everything from ticketing systems or case management systems, a SIEM or log management system, or some walled garden solution that emulates one or everything there. MISP can link into all of these tools. I'm listing open source tools here, but closed source stuff, everybody is making use of APIs these days. So being able to integrate MISP into those tools is definitely doable. And so here's a bunch of use cases here. So I have different data sources. I have internal tools that are being fed, and then also kind of a demonstration of how a single MISP install kind of works when you have multiple different organizations inside of it. So on our left-hand side here, we have potentially paid API threat intelligence. So maybe you're paying for virus total. And you see Cortex there. Cortex is kind of it sits in the middle of those and then provides a single interface to accessing multiple different API interfaces. It's an open source tool. It's a little bit aged in my opinion, but it's still very useful. You also have access to free public block lists, and that's everything from text files that, you know, the emerging threats block list, spam house block list, that kind of stuff. That's all things that you can add into MISP as ways of detecting malicious activity. External ISACs, you can have kind of a two-way connection with your information sharing organizations. So they can potentially see things that you're working on and you are seeing potentially things they are working on. And this is a great way to very quickly collaborate, because when you have something that pops up, you create an event inside of MISP, and then all of a sudden it says, hey, by the way, there's this other event over in ISAC that matches some of the IOCs that you're talking about here. And that gives you an opportunity to take a look at what they're seeing and get additional details. Affiliate organizations, somebody else can spin up MISP, or you can set up a relationship using a threat intelligence sharing protocol like Taxi. And so that's some of the inputs there. On the inside of MISP there, we see other orgs, for instance, KU, KUMC, and then you can set up sharing rules where information that, for instance, KU shares, you can potentially set up that event to only be shared to .edu spaces. And so that information is only viewable by other colleges, or you can make it global.
So are you sharing those? Or
We have a installation right now.
Okay.
It is not public, but we can certainly federate with people. And right now we have to have some conversations on data governance, on to what extent we want to share. But I've put into place kind of mechanisms to control that sharing and to prevent oversharing. And I'll go over some of those details on how to do that. Okay. You also have a feed of a warning list, which is IOCs that are actually false positives. And then whenever you create an event or whenever you see an event, it will tag that IOC as a potential false positive, and then it'll tell you why. This is very valuable to all of us, because I think, at least I've had a experience where I blocked things and then all of a sudden state testing stopped working. I don't know why. Things are so intertwined with content management systems and the cloud and all that kind of stuff, where the relationships between cloud providers and applications isn't always transparent. So even on, for instance, Palo Alto firewalls or any other firewall provider that provides App ID as a means of setting up firewall rules, you can potentially be put in a situation where the App ID, because it can't see into TLS encrypted traffic, it just has to make some guesses. And often I've seen those guesses turn into, well, state testing stopped working. Well, of course I unblocked that. And
your request to be unblocked that.
Say it again?
You have to request that app ID to be.
I think in that particular case, I just stopped using app ID rules, and because I was just beginning to implement them, so I didn't have a huge investment in doing app ID rule-based firewalling at the time. So, but that's the importance of being able to tell ahead of time if the threat intelligence feed you were receiving has potential false positives. I've seen FBI flash reports come through almost completely comprised of cloud provider IP addresses, which is very difficult. You can't just put that into the firewall and block it, and you know that just causes problems. At the bottom here, we have our case management system or ticketing management system. And you can potentially either enrich or set up automations so that whenever you create a new case, you can also have automations where it generates a new event inside of MISP. And so you can kind of start having kind of a one-for-one relationship. That would require kind of a SOAR system to make that happen, but it's possible. And then SIM enrichment, the API is actually pretty easy to use. And so I've successfully set it up inside of Graylog and some other open source things, but it shouldn't be very difficult to set up in Splunk or any other product. And of course, firewall, I have kind of a picture there of an M, and that is MindMeld, which is an old product, but it's very useful for pulling in threat intelligence feeds or lists and then combining them into a single firewall block list. And so that's a good kind of in the middle kind of tool. And of course, if you have an internal network IDS, you can pull in some of those rule lists where now, instead of having vague and very oddly specific open source for network IDS rules, now you have something that's very specific that matches up to a MISP event that gives you full context and an explanation of why that IP or IOC, is considered bad, and you can get an idea of what you should do about it. So that's kind of the MISP ecosystem here of how it can be used. Tagging. It's all about tagging. So tagging, like I said before, you could do, you can tag sources for, like, for instance, here's the Admiralty code. Traffic light protocol, which is I'll go into detail about that here in a little bit because that's something you will see a lot. You can also tag something as, I know this is false positive. This is bad information. Or if it's a known threat actor, you can tag it as that threat actor. You have a lot of flexibility there, but there's some standardization which allows you to do some automation to it. And so you can potentially have some built-in automations where every time you see a new high-level threat actor to create a new event or something like that. So there's some automation capability built into MISP that is very useful when working with tags. There's also internal and global tags. Internal tags are good for internal workflow. You can start something up and just give, if it detects that you're wanting to share it, it can yank back that sharing and then add a whole bunch of internal tags saying, hey, check this for privacy issues. Check this for, make sure it's tagged with the traffic light protocol. So you have a couple different options there for tagging. And then I mentioned before traffic light protocol. So you will see this a lot. Red is when you tag an event that you create. If it's red, it's intended for named recipients only. It means if you're in the middle of an incident and you don't want to share, you want to tag that as red. And that's good when you set up automations because then you can set up filters. So any type of red event will not be shared outside of that site. Amber is limited distribution, so within a group or a set sharing group. Green is community-wide, meaning that you might want to, green would be something you share to potentially other universities or colleges or education institutions, but not the general public. And then clear is general public. So sharing is controlled in MISP using tags. You also have the ability to create group sharing blueprints, which sets a set of tags or other aspects to the event where you can filter it. So you set up the event, you set it to go to a sharing group, and then that sharing group will filter based off of your blueprint. You can also do event filters just on the system itself. And then workflows, it has a very strong automation capability. So you can set up workflow hooks to perform custom automations. Like for instance, if a new event is created and shared globally, it'll yank back that sharing and start adding internal tags saying, hey, have you done this first? Some of the open threat sharing, I think this computer's possessed. They were having problems with it yesterday.
Is the mouse.
Yeah. So, in any case, STIX is a open threat intelligence sharing protocol. It's based off of XML and JSON, so you'll see that a lot. Taxi is kind of a sharing protocol, so it shares STIX objects so it's kind of like on a blog where you have RSS feeds. So basically, Taxi is a feed system that feeds out STIX objects. Oh, come on. Okay, output. So you have lots of options. You can do NIDS rules, text files, CSV, XML files. You can take an individual event or set of events and then export them, which is very useful for communicating with people internally and externally. So this is how you'd go about creating a MISP event. And first step is go into event actions and then add an event. Key things here is that there's a threat level. The threat level is steps removed from Godzilla. High is Godzilla. So medium would be something, another kaiju, another giant weird monster. And then low would be, we're not sure what it is. We think it's a mutant snapping turtle. But so when you're tagging a event, keep that in mind. How many steps away from Godzilla is this? Usually it's safe to say, I don't really know. Also, you can choose which sharing group to share this event to. Oh, come on. All right. Next step, you want to assign it a flag. So we talked about the traffic light protocol. Go ahead. Okay, sorry. And then you can assign ATT and CK. So basically go through and what tactics is this threat actor using? And so this has multiple different ways to add in the ATT and CK model values. An optional item here is you can set up templates. So if you need to set standards for creating events for your organization, you can create those standard templates and then publish. So publishing assumes you want to publish it to everybody, and it sends out email blast. It sends it out to everybody. This is only for things that you want to share to everybody. So you don't have to publish, and most of the time you won't be publishing, but this is an option. And so you also have the option to publish without an email.
So it doesn't look at your tags, if you have the red, yellow.
It will warn you. It will say, hey, you tagged this as red. Are you sure?
So it goes do not affect.
Yeah. Boy. So this is an example of a CISA alert that they sent around in STIX format. So they use a lot of tags here with the MITRE, ATT, and CK. So you can see all the attack things there inside the tag space. Looks like a unicorn barfed. This is another one by an organization called CRCL. It's very simple, but it has IOCs attached to this. And so this is another example of how you would use this. So when federating with other instances, it's pretty simple. You create an account on the host system and then you set it up as a sync account. And then it will generate a special key, which you add to your MISP instance. And then your MISP can reach out and start sharing events with that host system. So this is a way that you can connect together multiple different MISP systems. Some lessons learned. Stakeholders, primarily it's a security operations team, but network and systems all have a role to play in this. There is some care and feeding to keep this up, keeping this up and going, because the database can get quite large. And depending on how many systems you have using the API, you might want to add more resources, memory, and storage. It's a LAMP stack, so it's not something I recommend putting out directly on the internet. You'd want to control access using a firewall.
Virtual or physical?
You can do either. If you really needed a lot of horsepower, then a physical machine would be a good idea, but I recommend virtual machines just because of maintenance. You can also use, I believe there's also Docker images out there available for it. That is probably the easiest way to go, at least in testing. Data governance questions. Make sure you understand how the workflow features work. Then by default, MISP is very permissive, so keep that in mind. So when you build it out, make sure you start building in controls. And you can enable enrichment for just one organization. So it's a feature where you can click on an IP address and then you can have it go through and use your VirusTotal API, and that's built into the system, and then it'll allow you to create additional objects inside of that event from that API enrichment. And so you can potentially get additional hashes or IP addresses or information from VirusTotal or some other API service you subscribe to. All right, so here's some of the sources that I kind of learned from. First and foremost, if you're interested in the MISP project, www.misproject.org. And if you're interested in threat intelligence, here is some books. I think one of which here, I mentioned Andrew Northern. He did a talk at the FBI conference at KU this year. Intel is like ice cream, a sweet approach to intelligence. So he works, you might want to talk to Proofpoint downstairs because he works for Proofpoint. He does a lot of their stuff, and that was a really nice talk. So then also operationalizing threat intelligence. That was also a good book. Here's some generic sources if you're looking for threat intelligence or looking, like for instance, if you want more information about the traffic light protocol or how STIX works. So here's some resources for that. And if you're interested in how project management works, here's some notes on that. So thank you very much. Is there any questions I can answer? Okay, so if you are interested, I have some additional notes on how to do source evaluations. I kind of chopped those out for brevity, but I'm more than happy to answer any questions you might have. Just send me an email. Before we get, go ahead.
Sorry, I do actually have a question about evaluating the quality of, threat intelligence that you're receiving. So there's a lot of these different, a lot of different ways that you're evaluating them. Is there some programmatically that you have ideas about?
Qualitative versus quantitative?
Right, exactly.
I haven't seen anything that's quantitative. Quantitative, it's kind of like in managing threats, you can turn everything into a dollar amount, potentially, if you have an organization that tracks things in terms of money. A for-profit company is very good at that. And so you can do a quantitative analysis on risk and turn that into, we have a potential loss, and then we can fund resolving that risk by the savings versus that potential loss. That's not something I've seen so far. It doesn't mean it doesn't exist. Qualitative analysis, so basically going through and looking at those different dimensions and then giving a composite score based off of your findings makes the most sense, because you can also do stuff where you can do a statistical analysis or going through IP addresses and doing a spot check using a random sampling. And so that's another way to go about it. That might be a little bit more accurate. But some sources aren't, you can't really do that very well with. And it's kind of time consuming. And so that's why you have to do kind of a sampling. Does that answer your question?
Yeah.
Okay. Anyone else? All right. Thank you.
Thank you.
You